All right, so thanks, Ian. Now we'll talk about some of the key RF specifications for the transmitter and how they're measured. Sound good?
Fine, no problems. So, performance specifications for a transmitter are just separated into desired and undesired aspects. So in other words, what comes out at the desired frequency versus what else comes out that you really wish didn't. The major desired specification, obviously, for a transmitter is the actual output power on the frequency that you want. That's what's really conveying the information. So this is the level of RF power transmitted at the desired frequency, usually measured in watts, although sometimes dBm. Tait base stations, mobiles and portables are designed to transmit particular levels of RF power. A higher number is better. Generally, the more power generated, the further away the signal can be picked up by the receiver. But typical output power levels of Tait radios are, say, for base stations, it'll be 50 watts or 100 watts. And then for the terminals, mobiles, the standard was 25 watts. More recently, we've done higher power ones, 40 watts, 50 watts. And for a portable, it can be anywhere between 3 and 5 watts, depending on the band.
So if my knowledge is right, that means that a base station can transmit a lot further than a mobile, and a mobile can transmit a lot further than a portable, correct?
That's the idea, yes.
Yep. So you talked about this is obviously something that is desired. What are some of the undesired things that come along with that?
But radio transmitters always emit smaller amounts of energy at frequencies other than the desired one. So if you start thinking of where some of the energy is, some of the energy that's emitted is in the adjacent channel. So the channel right next door to the one you're actually transmitting on. Transmitters produce small amounts of RF power outside the channel they're operating on. The amount of RF power produced in the neighbouring channel is called adjacent channel power. So it's usually quoted in dBc, which simply means dBs below the power generated in the wanted channel. For that, a larger number is best. So 65 dBc is better than 60 dBc, for example.
Okay.
And a transmitter with lower adjacent channel power will allow a radio operating on an adjacent channel to get closer to the site before it causes interference. In short, transmitters that produce lower adjacent channel power contribute to a more reliable, robust system.
Okay. So talk to me about sideband or wideband noise, Ian. What's that about?
Okay, well, if you look further out than the adjacent channel, transmitters continue to produce small amounts of RF power well beyond that adjacent channel. Sideband noise is actually the power produced by the transmitter at large offsets from the operating frequency. It's usually quoted in dBc per hertz for specific frequency offsets. And again, a lower number is better. Minus 160 dBc per hertz, which is roughly what a Tait base station will achieve, is better than minus 150 dBc per hertz, for example.
Okay.
So at a radio site, sideband noise from co-located transmitters can actually deafen the receivers operating nearby, even though they're quite widely separated in frequency. So that means distant terminals would be unable to reach the site, preventing communication. Site transmitters with better sideband noise performance require the addition of fewer expensive large cavity filters to attenuate the noise below the level where it will deafen neighbouring receivers. So that results in better coverage and less sites required to cover the area, and reduces the system size and cost.
Okay, well now we'll take a look at the receiver RF performance advantage.